Okay, today we're going to talk about multiplying and dividing rational expressions. This is pretty easy because the way you do it is the same way you would multiply regular fractions, in the same way that you would divide regular fractions. The only thing that's specific to rational expressions is that you then need to simplify them. So, we're going to go through some examples and you will see that multiplying and dividing is pretty easy. So, remember, to multiply your fractions, you multiply across the numerator and across the denominator, and then you're going to simplify. Alright? When you are dividing, if you have a complex fraction, I'll show you what that is. Rewrite it using division and non-fraction bar. We have an example like that I'll show you. Remember, when you are dividing fractions, you change the division to multiplication and flip the fraction after the old division sign. So you're going to change the multiply and flip. Alright? Then multiply across the numerator and denominator and simplify. So we're going to go through these steps with some examples. So our first example here is very simple. So the way that I go about doing this is multiply across my numerator and denominator. So when I multiply across here, I've got 2xy b to the third. On the bottom, I've got 4, and I'm just putting everything in the same order that I had it, x, y, a, b. And the reason I wanted the top and the bottom in the same order is because I want to cancel each term individually here. So first of all, the 2 over the 4, 2 goes into itself once and into 4 twice. So I'm going to get to the end here and I'm going to have a 2 on the bottom. Out of my x's, I have the same on the top and bottom, so they're going to cancel. Out of my y's, I have the same on the top and bottom, so they're going to cancel. On the bottom, I have an a, but I don't have one on top, so I'm going to have an a on the bottom. And out of my b's, I have 3 on top, 1 on the bottom. 3 minus 1 is 2, so I have b squared on top. That's all there is to this. Now, if we take a look at example B, one of the things that we're going to need to do here is we need to factor. Because remember, we have to factor this in order to simplify. And I'll show you that if you just make your first step factoring, this is pretty easy. So in my first numerator, I can factor out a greatest common factor of a squared. In parentheses, that leaves me with a minus 6. In my denominator, I need 2 numbers that multiply to negative 3 and add to positive 2. So how about positive 3 and negative 1? So I'm going to have a plus 3, a minus 1. All right, next numerator, I'm going to factor this. I need 2 numbers that multiply to positive 1 and add to negative 2. How about negative 1 and negative 1? So this is going to give me a minus 1, a minus 1. And in my denominator, I have a to the third. All right, my next step is I'm going to cancel. All right, so I'm looking for factors that are common to a numerator and a denominator. So I have an a minus 1 on top and an a minus 1 on the bottom, and I can cancel those. Next, I have an a squared on top and an a to the third on the bottom. I have more a's on the bottom. And I have, in fact, 3 minus 2, or 1 more a. So I can cancel these, and that will leave me with an a on the bottom. All right, I don't see anything else that I can cancel. So at this point, my next step is to multiply what's left across my numerator and denominator. And that's going to give me a minus 6 times a minus 1 over a times a plus 3. My next example is a division example. And in this particular example, we got to remember how we divide fractions. So, my first fraction stays the same. I'm going to change division to multiply, and my second fraction flips upside down. So I'm going to have a to the third x over 3y. I'm going to multiply across my numerator and denominator. So in my numerator, I've got 6 x squared y a to the third. And on the bottom, I've got 3 y a squared. And now I'm going to work on canceling here. So 3 goes into the bottom once and into the top 2 times. So on the top I'm going to have a 2. When I look at the x's, I only have x's on top, so I'm going to have an x squared on top. Out of the y's, I've got 1 on the bottom and 1 on the top, so they are going to cancel each other. And then out of the a's, I've got 3 on top and 2 on the bottom. 3 minus 2 is 1. That leaves me with 1 on the top. And I'm done. All right, let's turn the page and we'll do some more examples. Some that are a little more complex, maybe. So this first example is multiplication, so no flipping involved. First thing I'm going to do, factor. All right, so out of my first numerator, I have a greatest common factor of 3x. Always look for that GCF first. In parentheses, that leaves me with x minus 2. In my denominator, I need two numbers that multiply to positive 9 and add to negative 6, which would be negative 3 and negative 3. So x minus 3, x minus 3. Here, two numbers that multiply to negative 6 and add to negative 1. So how about negative 3 and plus 2? And in my denominator, I have the difference of 2 squares, x squared and 2 squared. So this is x plus 2, x minus 2. Okay, now that I have factored everything completely, and this is why I expect you to show work when you work these problems, because there is work to show, we're going to cancel. So first of all, I want to cancel one thing from the top and one thing from the bottom. I've got an x minus 2 here and an x minus 2 on the bottom. If they're both on the top, you can't cancel them. If they're both on the bottom, you can't cancel them. You have to cancel one from the top and one from the bottom. I have an x minus 3, one on top, one on the bottom. And I have an x plus 2, one on the top, one on the bottom. And so what I'm left with is 3x over x minus 3. And remember, we cannot cancel the 3's and we cannot cancel the x's because we cannot cancel things that aren't factors. We can't cancel parts of binomials. All right? Let's go to the next example, which is a division problem. And this particular division problem, let's rewrite the first fraction. Change the division to multiply and flip the second fraction upside down. Okay. If you like to cancel when it's like this, I really don't in general. I know some of you do. I'm going to cancel the 3 and the 9. So 3 goes into itself once and into 9 3 times. I'm not going to try and cancel any of my variables until I get this all written out. So I've got 5 in the numerator. C to the 4th times C to the 7th is C to the 11th. Then I have a 3 times 2 gives me 6. And I have a squared times a, which gives me a to the 3rd. All right, and now there is nothing I can cancel at all. So the 9 and the 3, that was it. All right, let's go to the next example. This is a division problem. All right, we'll try and do this in a minimal number of steps. So we're going to factor while we change to multiply and flip, okay? So the first thing I'm going to do, factor this first fraction. So I have 1 and an x squared. This is the difference of two squares, the square of 1 and the square of x. But this is not x plus 1, x minus 1, because the 1 is first and the x is our second. So it's 1 plus x, 1 minus x. On the bottom, I have 3x plus 4, and there's nothing I can factor out of this. I'm going to change this to multiply, and I'm going to flip this upside down. And I'm going to factor while I'm doing that. So I have to factor this, but I noticed something here. This is 3x times itself. This is 4 times itself. And the middle is 3x times 4 times 2. So I know this is 3x plus 4 quantity squared. And that was on the bottom, so it's moving to the top. And this I need to factor if possible. Something that multiplies to -2 and adds to +1. So how about +2 and -1? Okay, now we're going to cancel. So if I look at the 3x plus 4s, I've got 1 down here and 2 up here. All right, I just want to cancel one of them from up here. So I'm going to cancel this, and it's going to get rid of this and make it a 1. Now, out of the rest of this, I have a 1 minus x and an x minus 1. These are not the same thing. All right, they are different. We talked about this the other day. What you need to do is pick one or the other of them, and it doesn't matter which. And I'll just take this one. Factor out from it a -1. So when I factor out a -1, what's left in parentheses is -1 plus x. And now what you see is that -1 plus x is the same as x minus 1, because all the signs are the same. So I can cancel this. But remember, I've got a -1 left in this numerator. I like to put negatives out in front of the entire fraction. So in my answer, I'm going to put a negative. In my numerator, I have 1 plus x, which just FYI is the same as x plus 1. And then I have 3x plus 4 over x plus 2. All right, let's go to example D. And this looks really weird, I'm sure. This is what we call a complex fraction. And what that means is we have a fraction in a fraction. Complex fraction. So remember something. The fraction bar means divide. So we can write this as a division problem instead of as a complex fraction. So here's what I would have if I did that. I would have a squared minus 4ab plus 3b squared over a plus 2b, and this is divided by a squared minus ab minus 6b squared. All right, now I have a division problem, and we know how to do division problems. We're going to change it to multiply and flip this upside down. And I'm going to factor as I do this. So here I need something that multiplies to 3 and adds to -4. How about -3 and -1? So when I say -3 and -1, remember they're going to have a b with them. So I'm going to have a minus 3b and a minus 1b. And this is over a plus 2b. Change the division to multiply. Flip this upside down. Keep in mind, this is easy to flip because if you don't see a denominator, there's a 1 there, right? So when we flip this upside down, we will have a 1 up here. Now I need to factor this. So I need something that multiplies to -6 and adds to -1. How about -3 and plus 2? So that's going to give me, because I've got the b's with them, a minus 3b, a plus 2b. All right, now I'm going to cancel. So I've got an a minus 3b on the top and on the bottom. So now that's the only thing I can cancel, because I can't cancel these because they're both on the bottom. One has to be from the top, one has to be from the bottom. So now just multiply across. On top, I've got a minus b. On the bottom, I've got 2 of these. So let's write it like this. A plus 2b quantity squared. Now, our very last problem is important for us because it includes both multiplication and division, and it's important to know what to flip and what to keep the same. When you have a problem that has both multiplication and division, or it has multiple divisions, you flip anything that comes directly after the division sign. So, in other words, we will flip this because it comes right after a division sign. This comes after a multiplication sign, so it does not flip. All right? So now, what we're going to do, flip what's necessary, and then we can multiply across the numerator and denominator. So this gives me 6p squared q over r times, flip this upside down, r over 3p q squared. This one comes after division, so it doesn't flip. So this is 2q squared over pr. Now, I can try and cancel some of this. I don't like to cancel a lot of stuff when I have a lot of variables because I tend to make mistakes. But this is simple. Here's an r and an r. One on the top, one on the bottom. So I'm going to get rid of those. The other thing I'm going to do is do my 3 and my 6. 3 goes into itself once and into 6 2 times. You know what else I see that will cancel really nice? I have exactly a q squared here and exactly a q squared here. I can get rid of those. And let's see what I got left and see if I can simplify further. So first of all, 2 times 2 is 4. And I have p squared q. On the bottom, my coefficient would be 1. Here's a p and here's another p, so that's going to give me p squared, and then I have an r. So when I look at this, I'm going to have a 4 on top. The p squareds are actually going to cancel. I'll have a q on the top and an r on the bottom.